All right, good afternoon, 4B. Here I am making a video because I'm not here today. Hope you're doing well. We need to get through a good amount of these notes today, and so I'm going to make this video, and you should be taking the notes, leaving Miss Reno alone, and take the notes. Make sure you pause it when I tell you to pause it, and write it at your own pace. But this is a really, really important section. It's super, super, super useful, and we end up doing a lot of different math with it. And so you need to make sure that you pay attention to this as much as you can. We will finish this material on Tuesday, and so do this as to the best of your ability. Be as intentional as possible. So where I want to start is where we left off last time that we met. And this is a triangle congruence statement right in front of me here, and I'll be using my iPad here. So here's my first triangle, triangle ABC, and here's my second triangle, triangle DEF. We're saying that those are congruent. And just as a quick warm-up, what you should be thinking about is, what does this statement actually tell me? And so in the front of your packet, if you have a second, go ahead and write down the pairs of angles that you actually end up seeing from this, and the pairs of sides. Because as we know from last time, there should be 6 different things that we can write down. Pause me, go ahead and write down those 6 things really quickly in the front of your packet. Okay, so the 6 angles that you see, we have angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Again, what we're looking at here is my first letter is A, so my first letter over here is D. The second letter is B, the second letter over here is E, and the third letter is C, the third letter is C. The order and the location in the triangle congruence statement really impacts what we know. For the sides, it's very much the same idea, right? The first 2 letters are AB in the first triangle, and so that one's going to be congruent to side DE, the first 2 letters over there. And the same pattern exists. The second 2, are BC, and that's going to be the same as EF, the second 2 on the right side. And of course, AC, the first and the last, is going to be congruent to DF, the first and the last. I apologize for my dogs barking. So these are the 6 different things that we can say based on these triangles right here, this stuff right here. And so the biggest thing that we should take away from last time is that if I was given 2 triangles, right, we said here's triangle number 1 and here's triangle number 2, right? And we wanted to conclude that those triangles are congruent, which they clearly are not based on how I drew it. But if we wanted to conclude that they're congruent, we would need to show 6 things. We would need to show that these 3 pairs of angles all match, and we would need to show that these 3 pairs of sides all match. Which of course is a crazy amount of work. And so a big part of this chapter is, what can I do to minimize that work, right? What can I do to make this easier? So it turns out we're going to learn 5 different angle theorems, or triangle theorems, excuse me. And these 5 theorems are the accepted ones that we can use. Now, I'm not going to prove them today. I will probably show you a proof next time we meet. But for today, I'm going to show you the 5 options, and we're going to practice using them. And this is a pretty tough lesson to learn for the first time. It's a really hard topic, and so you want to make sure you're doing this with a good amount of effort, right? As we're taking this and practicing it, I promise you it's going to go better if you just pause me. And we're going to be pretty extra about how we write notes today. So our first one is called the side-side-side congruence theorem. The first 4 are all combinations of the letter A and the letter S. And so this one says if 3 sides of one triangle are congruent to 3 sides of a second triangle, that's enough information to conclude that those 2 triangles are congruent. Instead of showing all 6 things, we just need to show that we have these 3 pairs of matching information, right? And you have a bunch of ways to look at this, right? You can say, well, I have a side, and a side, and that information matches on both triangles, and so this is side-side-side congruence. And so the work that we're going to show looks like this. So here's our example. It says decide whether the information is given, enough information, is given to prove that the triangles are congruent using side, side, side. If they're congruent, write a congruent statement. So what we're going to do is we're going to look for three pieces of information, right? Because side, side, side requires us to have three pairs of sides that match. And as we do these, you will see a bunch of tricks that come up in this section. So right here, the first step is looking at the picture. Is there anything else that I can mark? And now we talked last time about there's the shared side right in the middle here that we can mark. And the logic here is that if I were to break this up into two pieces, right, and draw the triangle separately, those two triangles would have LM on each triangle. I'd have to redraw that triangle, that segment twice. And so the logic that we talked about was this is called a shared or common side. That's a shared side. And so we're going to mark that one. And so the three different pieces of information that we have KL as a segment is congruent to LN. That's our first pair of sides. We have KM is congruent to MN. That's our second pair of sides. And our last one is that we have LM in the first triangle is congruent to LM in the second triangle. That's the reflexive property. So those three pieces of information highlight the three sides that we're marking. And this is enough to conclude that by side, side, side congruence, right, we can use the side, side, side theorem, triangle, and now we can write our triangle congruent statement, right? And again, we choose the order that we go in. It doesn't matter for the first triangle. Say we do KLM. Now we need to make sure that we match our order. So if we chose K first, the first letter on the other triangle is going to be N. And then we went to L. So K to L, we need to go to L again, along the one tick marked option, right, from K over to L. So we're going to go from N over to L. And then, of course, we jump down to M. So here's our triangle. So again, three pieces of information, right? S, S, S. And that allows us to conclude by SSS that these triangles are actually the same triangle. Okay? There's the logic. And you're going to see that all 5 theorems today have 3 pieces of information that we need to check. Okay? Now this is a lot. This is a ton of information. This part right here, I'll circle it in purple, likely will feel overwhelming today. And that's okay. We're going to practice this, but this is the information that we want to show. This leads us into proofs, and this is something that we can easily do. Our second theorem is called side-angle side. So now is when it gets a little bit more tricky, because before it was just do all 3 pairs of sides match. So this one says if 2 sides and the included, and we're going to highlight the word included right there. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the second triangle, then the 2 triangles are congruent. So side angle side as a theorem very much tells you where this angle needs to be marked. Because we need to have it so that we have 2 sides, right? The 2 sides need to be marked as they are in these 2 triangles. But that third side, or that third piece of information, it's not going to be a side, it's going to be an angle, needs to be in the middle of those 2 sides. And so you need to make sure that you're not choosing this angle or this angle, but instead choosing the angle that is included in the 2 sides. You see how the angle that I'm hovering right now touches both BA and touches CA? It interacts with both of those. It shares that it's a common angle for both of those sides. So that's going to be included, as we call it. And so we need to make sure it's the included angle. And another thing that is going to come up is that the information that is on both needs to match. And so in this case it does. And we'll see some examples of this happening. So here's another example. And again, we're looking at all the tricks. It says decide whether there's enough information to use side angle side. So here we have one side marked, and again we have a common side, so we can use that information as well. Now as you're sitting here looking, of course you see this, and you should know what this means, right? This means that these 2 lines, CB and DA, are parallel. Now if you think back, way back to chapter 3, we had a ton of information about this, and this means something to us. And so let me show you what I'm talking about here. So in chapter 3, we had lines like this. Right? This is the 2 parallel lines marked like this, being cut by a transverse. So this is all of chapter 3 was about this. And so it turns out that when you have this, you get a bunch of different angle pairs, say linear pairs or vertical angles or alternate interior angles, alternate exterior angles, and they all have relationships. So one that comes up a lot in this chapter, it comes up all the time, is that this angle right here and this angle right here are congruent. Those are alternate interior angles. And again, they are congruent as long as these lines are parallel. That has to be true. So this comes up all the time. So I'm going to take this, and I'm just going to borrow it quickly. Let's copy this. And I'm going to put it back over here. Oh, sorry about that. Nice and small. So this picture that I just brought over here, hopefully you can see some similarity between the picture that I've drawn on the right here and this picture over here, right? You should see that if I took and extended these lines with my little highlighter here, and I extended this line this way, and extended this line this way, and I extended this transversal this way, we have somewhat the same picture, right? And so it turns out that in this triangle, or in these triangles, we can actually mark this angle and this angle, or these angles and these angles. We can mark both pairs. Now, we don't actually want to mark both pairs, so I'm sorry if I just made you erase. But remember, the biggest thing about this is that when we do this, we want to have the included angle, which means ideally we would have this angle right here marked, because that one is included between this piece of information here and this piece of information here. So we can actually mark those two angles. That's totally allowed. Those are alternate interior angles. But again, we were just being a little bit strategic. This one up here would also, sorry, up here doesn't make sense to you. Right here would also work, but we don't need that one. That one's not going to be as useful. So here we have our three pieces of information. We have the first one, side BC is congruent to side AD. Our second piece of information, AC is congruent to itself. Of course, right, reflexive property. And our third piece of information, angle BCA, is congruent to angle DAC. Now, of course, we can't just use one letter here because it's not super clear what this angle would be. If you say angle C, you're talking about maybe this angle or this angle over here, maybe the whole thing, who knows? So we need to use three letters in this case. And these three pieces of information give us enough to use by side, angle, side. We can say that triangle, and in this case, let's choose the order ABC. It's a nice order. Is congruent to, zoom out a little bit, triangle ABC, and again match the order. It'd be in this case triangle C, because A is not marked over here. So C, D, A. On the other side. Okay. So hopefully that one makes sense. And you'll see the pattern here. These all are going to act the same way. Okay, so that's our first page. On to the next one. Here we have our next triangle theorem. This is angle, side, angle. So now instead of having two sides, we have two angles. And again, if you look at how the letters are arranged, right, you'll see that the side is in between the two angles. And that's very much true in the picture as well. This side that is marked needs to fall in between the two angles that are given. It's going to be called the included side. Okay, so to use angle, side, angle, it cannot be this side or this side. It needs to be the one that is in between the two angles. So here we have another picture. We want to see if we have enough information to use angle, side, angle. So of course we have one of the angles already marked, and you should be looking at this and going, is there anything else I can mark? And yesterday when I taught this, a lot of students screamed that I could mark these two, which is absolutely correct. Hopefully, as you're sitting here watching this, you're thinking of the name of those two angles, and of course they're called vertical angles. And we can always mark vertical angles. Those are always congruent. And so now we can get our three pieces of information that we need. Of course, it's going to be an angle, a side, and an angle. So our first angle is angle S. It's congruent to angle T, nice and clear, one letter. The middle ones will need a couple of different letters, but for the side, we have SV, congruent to VT in this case. And for the second angle, it's going to be angle RVS. Again, 3 letters if it's not clear. And then TVU is a fine option. Okay, so those are our 3 pieces of information. That's going to be enough to say bye. And of course, this one is angle, side, angle. Choose your triangle congruence order. RSV is congruent to triangle. And we need to go with UTV. Okay. So again, this is angle, side, angle. We're almost done with the theorems. 2 more. Here we have angle, angle, side. Now notice the difference, right? Both angle, angle, side and angle, side, angle have 2 angles and 1 side. So the only real difference between this and this is where the side portion is located. Right here it's going to be on the outside, here it's going to be in the middle. And so we need to make sure that when we're doing these problems that we're looking at the picture that we're given, because if you look on the right side over here, we have an angle and an angle, both as marked. If you have the side that I'm hovering currently, that would be angle, side, angle. But as it stands, if it's here or over here, those are going to be angle, angle, side. Okay? And so as we're going along here, here's our example. Now, this is the hardest one to picture out of all the ones today. And you can sort of see that we have 2 triangles drawn like this. Right? And those triangles would be K, L, that's not an L, that's not how L's work, L and M, and then K, N, and M. And so if you're looking at this picture, you'll see that I just drew the same side twice, right? And that is this side right here, KM. That is going to be our shared side. It's pretty tough to see, but let's go ahead and mark in our 2 triangles that we've drawn down here. And I have a hard time looking at this for some reason. So it's going to be like this. That's the picture that we have. So if you notice here, we have angle, angle, and then the side on the outside of them. Angle, angle, side on the outside of them. So this is a great candidate for angle, angle, side. So our 3 pieces of information, the first one is that we have angle L is congruent to angle N. So now when we're looking at this, we're looking at the big picture. You have to ignore your scratch pictures down here. So we need to use 1 letter for those, or we can use 1 letter. For the second pair, we can do another angle. So in this case, it's going to be angle LMK. That's the one down here. Is congruent to angle. In this case, it's going to be NKM. And for our side, of course, we have KM is congruent to KM. Now, for all 3 pairs of information that I've been doing, it doesn't matter. This order doesn't matter right here. We just need to make sure that we are indicating all 3 pieces of information somewhere, right? Because we need 3 pieces. It doesn't matter the order that we go in. It's just that we need the 3 pieces. So since we have 2 angles and the side on the outside, we have enough to say that by angle, angle, side, our triangles are going to be congruent. So we have triangle KLM, and here I'm looking at my little homemade triangles down there, and that's going to be the same thing as triangle, in this case, MNK. And so that's our first 4 theorems. We have 1 more, and then we're going to practice them. Our last one is called hypotenuse leg, and I know what you're thinking. That's only 2 letters. But there's still realistically 3 things to check. So the name hypotenuse leg should indicate to you that we are working with a right triangle, because hypotenuses only exist if we have a right triangle. And of course, we've talked about this before. The hypotenuse is the side that is across from the right angle, and the other ones are legs. So to do hypotenuse leg, there's going to be 3 things to check. The first thing to check is, am I actually working with a right triangle? The next 2 things to check are my hypotenuses marked, and is there 1 leg that is marked? That's enough information to use hypotenuse leg. And so here is an example. Again, we have that same shared side that we've been looking at, so we can mark this. And so here are the 3 things that need to be marked. Do we have right triangles? So right triangles, question mark. And of course we do, right? We have right angles that are marked there. It's pretty clear. So we can use hypotenuse leg. Then we have our hypotenuse, which is AC congruent to BD. That's marked. And we have BC is congruent to ourself, which represents a leg. in these triangles. And so that all combines enough information to say that by HL, we have triangle ABC is congruent to triangle, and again, check the order, DCB. Hopefully there's no questions on this. So here are some basic steps to check if the triangles are congruent, right? And the idea here is I've given you two triangles, right? And you want to know which pieces of information you should use. And so here are some steps your brain should do. First one is there enough information, and I'm reading along here and paraphrasing, is there enough information already shown in the picture to do your work, right? What congruent sides and angles are currently marked? Then the harder part is, what can I mark? Right? And we saw some good examples in the notes here. We saw vertical angles get marked. We saw shared sides or common sides get marked. We saw parallel lines causing us to have alternate interior angles. Those got marked. And then there's all kinds of other geometry that we can use. Some examples might be a midpoint cutting something in half, or an angle bisector creating two angles cut in half, or isosceles triangles having the base angles theorem. We have all kinds of things that we've learned. And so all this stuff might come into play here. Once you are done marking the picture, we've looked at the picture, we've looked at the marks, we've marked it ourselves. Now we want to choose the theorem that works. If none of our 5 theorems work, we're going to conclude that these triangles are not congruent. That's a little bit loose to say that because maybe we just don't have the information to show they're not congruent, but they're not congruent by what we know, that's for sure. And then lastly, you're going to write a congruent statement if possible. So if there's not letters, don't write a statement. If there are, then do. And again, we have 5 options. We have side, side, side. We have side, angle, side. We have angle, side, angle, angle, side, and HL. Those are the ones that work. Now, you might be wondering, and it's worth saying, that there are some combinations that we might run into that do not work. Okay? One combination is angle, angle, angle. Another such combination is side, angle, angle. Another one is side, side, angle. And then, right, earmuffs, don't tell anybody that we're writing this. There's angle, side, side, which of course is a terrible word. We can't say that in school. It's not school appropriate. So it turns out that one of these does work. It's actually this one right here. And it's the same thing as angle, angle, side. Please write it in this form because this is the name of the theorem, angle, angle, side is. So don't write side, angle, angle. It's the same thing. These two are actually the same in the same exact theorem in the same way, and neither of them works. The proof isn't super simple, but the best way to think of it is if it spells ass, it's not school appropriate, and you need to go ahead and not use it. So it's either that or that backwards, both bad words, can't use them. Okay, so don't, if you encounter angle, side, side, you cannot prove that those triangles are congruent. The angle, angle one also does not work, angle, 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 and I can show you why. Here's a little orange arrow over to here. And here's a very, very quick proof. Here's my first equilateral triangle. It's beautiful, okay? Just pretend it's equilateral. In an equilateral triangle, all the angles are 60, right? All 3 of those angles are 60. And here's my other equilateral triangle, which is also beautiful. Don't say a word about it. And all the angles in that one are also 60, right? Are those triangles the same? Absolutely not, right? This one is much bigger than the smaller one is. These are not the same triangle. So this is just a quick example of showing why angle, angle, angle does not work. And so we're going to stick to these 5 right here. Those are the ones that we want to be using. So the hardest part of this is not doing the individual problems, but it's being given something like this and saying, do it. Which ones do you use? So here's the thing is that we're going, I'm doing a video, and so I'm going to go through all of them. But I really want you to watch me do the first 2. And then pause me and try all the way through number 12. Cross out number 9. It's a repeat of number 6. But I want you to genuinely try all the way through until you get to number 12. Okay, I'm going to do 1 and 2. Please watch those. And then just pause me and do your best guess. And I'm talking mark the picture. That's going to be graded. And put your best guess. I'm not asking for any of the information to be written down. Literally just mark and which one do you see. It's going to be much, 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 much better if you can do this on your own than if I have to do it for you. Okay? So again, here's number 1. And I'm going to just watch me do this one. We need to mark the things that are there. So we have a shared side. I can mark that. I'm going to use 3 tick marks, of course. And then what I see is I have a side, side, side. I have all three sides marked. This is going to be side, side, side congruence. And that is all I want for these problems. That's it. Okay? But number 2, you see a new issue happen. On the right side, you'll see that I have this nice right angle. And I have the leg next to it. And I have the hypotenuse. That's awesome. But on the left side, you'll see that I have the right angle on the leg, but I don't have the hypotenuse. See that? And so the information that we have doesn't match. And so this one right here, this issue, causes us to say none. None of our theorems work here because the information that we're given doesn't actually match. Okay? All right, so at this point, you should pause me, and you should try 3 through 12 all on your own. Get as far as you can. Maybe work with somebody near you. Genuine college effort. What do you got? Okay? Resume me when you're ready. Okay, hopefully you just worked for like 10 minutes. Let's go through these. Here's number 3. We have a shared side. Once again, I see it right off the bat. I'm going to mark it. So now looking at this, I see 2 right angles. My brain goes, this is allowed to be HL. Right? It doesn't have to be HL, but it's allowed to be. And I'm going to check that first because it works for right triangles. And so I do see here that I have the hypotenuse. It's the one across from the right angle. And I have a leg on both triangles. So this is a great candidate for HL. Number 4. Here, I see vertical angles right off the bat. I can mark those. I know those are always the same. And so looking at this, I see that I have an angle, and I have the side that is in the middle of those 2 angles. And that's the same information over here. And so this is a great candidate for angle, side, angle. Because the side is indeed in between the 2 angles. Number 5. So here's another nasty candidate, right? Over here I have an angle, and the side on the outside. It's looking like it might be an angle, angle, side problem, right? But over here I have angle, and the side in the middle. So here the information doesn't actually match. And so we don't know any of the theorems that are going to work here. So we don't want to say that those are congruent. Number 6. Back to that nasty setup. We have that marked side here again. That's that shared side. And of course we have an angle, and a side. But the side is on the outside of the 2 angles. It's not included, so this is going to be angle, angle, side. Okay, hopefully you're seeing this pattern and how this works from here. Number 7, I again see a shared side. I'm going to mark it. And it's just a straight up candidate for side, angle, side. I have 2 sides and the angle between them, so pretty standard side, angle, side. Number 8, shared side once again. These get to be quicker and quicker. But now you see the issue. I have an angle, a side, and a side, and the only option out of our 5, right, here's our 5 again, just to remind you, the only option that has 2 sides and 1 angle is right here. Oops, sorry. 2 sides and 1 angle is right here. And side, angle, side requires us to have the angle in between the 2 sides. And we don't have that, right? It'd be right there. And since we don't have that, this one would be ASS, which is, of course, the ass postulate. We can't use that, so this is none. This is sad. Okay, it feels like that one should work, but it doesn't. Okay, so hopefully 1 through 8 went okay. On to number 10. Again, you should have tried these already, but this is a marked in the middle. It's a common side, and then we have angle, side, angle. Standard stuff, nothing to it. Down here, we have to look at this again. You see that we have a side in between 2 angles that are marked, right? Pretty standard stuff. So in this case, it's going to be angle, side, angle. Again, the side is included or in between the 2 angles. And for number 12, looking at this, I have the 2 sides and the angle between them. And your brain wants to go to HL, but it's not HL. We don't have the hypotenuse. It'd be right here. What we do have is a beautiful example of side, angle, side, where we have the angles match. Now, they're not technically marked as matching, right?
but they both are marked as 90-degree angles, and so of course they do match. Okay? All right, 3 more problems and we're done. I know it's been a long one. It's a very tough section, so you've been working for quite a while. So here we're going to start adding in a little bit more information. The same stuff works, right? We're looking at the picture. We need to mark our information that we see in the picture, right? Without even reading the words, I know that I'm going to have vertical angles right here. And you can just follow along with me here. There's no reason to try this on your own yet. But we were still working on the same stuff, but now we're going to start adding a little bit of auxiliary information, or information that we haven't seen in a while. So this requires us to have a really strong geometric vocab, and a very strong application of that vocabulary. And so here we've marked our vertical angles. That's great, but that is not enough information to conclude the triangles are congruent. And so what we have to do is we have to read this, and it says segment BD bisects segment AE. So I'm picturing myself standing in front of you asking you what the word bisects means, and hopefully you were sitting there screaming at your computer that bisects means cutting in half, right? So what this says is that segment BD cuts segment AE in half. So this segment right here, AE, is cut directly in half, which means that this side right here is the exact same as this side right here. And so now we get our 3 pieces of information. And we're going to write these again because we have the letters. So we know that given to us, angle A is congruent to angle E. And by vertical angles, we know that angle ACB is congruent to angle DCE. Those are marked in there. Those are 2 tick marks. And then because of that segment bisector, we have segment AC congruent to segment CE. That's our 3 pieces of information. And so of course this tells us, and maybe it's worth writing it over here, that we need to use angle side angle. That's maybe worth writing over here. So we're going to use by angle side angle. We can say that triangle, and again, choose your order, whatever you want to do. I'll go ACB, and that's going to be congruent to A is 1 mark, so E is the first one, C is 2, and is also C in the second triangle, and then D. There's our triangle. Okay, so not too much harder, but it is going to take a little bit more work. And so if you're sitting there and you're thinking, Larson, I'm watching a video and I don't understand where you got that from at all, and this is really hard for me, that's okay. It's day 1. We're going to practice this again on Tuesday, and we'll use that practice time to help us identify which one to use. Okay? Number 2, no words here, but there is a little bit of different information. So of course we have this marked side in the middle, the shared side that we can mark. And then we can just work with that from there. So pretty standard one actually. Here we have a side, we have this angle being marked, and then we have a side. So it's just side, angle, side. And so let's write down our informational pieces. So the first one is that AB is congruent to BC, and you can probably handle this if you want to pause me. The second one is that angle ABD is congruent to angle CBD. Don't forget 3 letters because this is not clear enough to say angle B, right? And our third one is BD is congruent to itself. Again, that's the reflexive property. And all this information lends us to say that by side, angle, side, and then our triangles. Triangle ABD is congruent to triangle, and now the order would be CBD. Again, this part right here, I'm starting to gloss over it, but this part we practiced last time we met. And we should be pros at that by now, right? We know that we choose the order in the first one, and then we match that order. Okay, super important. And our last one before you were allowed to stop is this one right here. We will finish the rest on Tuesday. Here it says B is the midpoint of segment AE, and B is the midpoint of segment CD. So what that tells me is that this segment right here, cut in half by B. This segment right here, cut in half by B. So I can use the information written to mark this and this, and also this and this. Now, I can't use the same amount of tick marks. I don't know that AB and DB are the same size, but I can do this. Now that's just from the words that are up here. And now, hopefully you're sitting there thinking, I know what else I can mark, right? What else can I mark? Well, the vertical angles. And so this information in the triangles that is marked currently allows us to use side, angle, side. And so let's write down our 3 pieces of information. Our first one is AB is congruent to BE. and DB is congruent to BC, and angle ABD is congruent to angle CBE. The three things that we have marked, the three things that build side angle side. And of course, this tells us by side angle side, triangle ABD is congruent to triangle EBC. And we did it. Tons of work. So at this point, you've seen most of what we're going to be doing. You can make really, really good progress on that homework. Please work through the end of the period and do what you can to remain quiet. I appreciate you taking these notes and watching this video. I hope you have a wonderful weekend, and I will see you on Tuesday.